So hello all, welcome to the tutorial session 11 on the course structural analysis. Today we will first briefly discuss about the contents of week 11 lectures. Mostly today we will deal with displacement methods. And to be more precise, we will deal with MDM. MDM is movement distribution method. One method which is a type of displacement method. And we will deal with problems related to statically indeterminate beams and frames using this method only. In today's class, we will solve all the problems related to statically indeterminate structure using MDM method only. So let us proceed further. This slide is a repetition of week 10 slide to keep you in touch with what we have done in previous week and what we are going to do today. So in previous week also we have discussed about displacement method, and more specifically in week 10 we discussed about slope deflection method. And in today's class about MDM, that is moment distribution method. Both are types of displacement methods. So I have said it many times, as the name suggests which method is coming. If that is force method, then the unknowns will be forces. Forces does not mean only force, it can be movement also. And when displacement method, if the name suggests displacement, then what will be the unknowns? The unknowns will be displacements. So displacement can be translational or rotational in nature. And it depends upon the kinematic indeterminacy of the structure. Means if the kinematic indeterminacy of that structure is rotation, then your unknown displacement will be rotation. If the kinematic indeterminacy of that structure or of that joint of a given structure is translational in nature, then your unknown will be delta, which is translational unknown. Or suppose in this frame, so when you go, let this be joint 1, let this be joint 2, and this be joint 3. So when you will calculate the Ki, you will get at this joint, you will have 3 degrees of freedom. 1 along X, 1 along Y, and 1 rotation. Similarly, when you go to joint 3, you will have only rotational degrees of freedom. But this delta X2 and this delta Y2 and delta Y2 will be present as unknown if the members are flexible, second is rigid. Which one is correct? If the members are flexible, then delta X2, delta Y2 degrees of freedom will be there or not. Or if the members are rigid, delta X2 and delta Y2 will be there or not. Which option is correct?
Sir, I think rigid.
Uh, read the statement once again and tell me what you are telling. And don't tell me the options only. If you are telling some option, then tell me why that is.
Okay, okay.
Take your time. Take 1 minute, think and tell me.
Delta x2 and y2 will be present as unknown if the members are. My bad, sir. Actually, if the answer is not rigid, then it must be flexible because uh, if the joint is rigid, then there is no chance of the displacement.
Yeah.
So
So,
that's why it must be flexible.
yeah.
That's why only we get the rotations and translation further in.
So, delta x2 and delta y2 will present as degree of freedom if the members are flexible in nature. If the members are not flexible in nature, then the length of the members won't change. If the length of the member won't change irrespective of any loading condition, then this joint cannot move either in x direction nor in y direction. If that joint cannot move in x direction as well as in y direction, then those translational degrees of freedom are arrested. Hence, your degrees of freedom reduces, and your degrees of freedom will be, for flexible case, it will be theta 2, delta x2, delta y2, theta 3. And for rigid, it will be theta 2 and theta 3, whereas delta x2 will be 0 and delta y2 will be 0. The reason is the members are rigid, which in turn implies that the length of the members cannot change. That is the reason when the members are rigid, your degrees of freedom are less compared to when the members are flexible. Till this point, everything is all right?
Yes, sir.
Yeah.
In the
Now,
decay, yes, sir. You have told to go through the concept properly while you are teaching the indeterminacy concept.
yeah, that is the reason I said that is the most important thing, and most of them think like all only if you mug up the formula you will get the answer. But I have also shown you formula might fail somewhere. Your
Yes, sir. Yes,
visualization won't fail anywhere.
yes, sir.
The
Now I got.
second, the second statement is in displacement method, the equilibrium conditions are satisfied at joints to determine the unknowns, and the unknowns are displacements in nature. But when force method comes, then what thing we generally satisfy to get the unknowns, that are movements or forces? Those are compatibility condition. Third point is, this is a important point, and it is not a hard and fast rule also. If Ki of the structure is less than the dsi of the structure, then displacement methods is preferable. It is not hard and fast that if Ki will be less, then only you can apply displacement method. then only you can apply displacement method. But force method can be applied, but it will be cumbersome because of larger amount of unknowns present in the problem. And the last point is different types of displacement method. We have dealt with slope deflection method previous week, that is week 10. Stiffness matrix method is the topic of discussion for next week. Fanage method is not there in our syllabus, and moment distribution method we'll deal today. That is our main purpose of today's class. So, before going to moment distribution method, first we should know some important terms related to moment distribution method. First, we should know what is stiffness. Stiffness of a member. Stiffness, when you tell, it is defined as force required to cause unit displacement. So, if someone asks you what is flexibility, how you will describe it? I know it is the opposite of stiffness, but don't describe it like that manner, but describe it in a sentence.
Flexibility. Yeah, you
Yeah.
told. What's that?
See, if you're forgetting, then you think there are two
Unity.
methods, displacement methods.
Their force will be unity.
Displacement methods and force method.
Yes, sir.
So either your unknowns are displacement or your unknowns are forces. You only have two components in your hand. If you are describing stiffness as force required to cause unit displacement, means you want at some joint your displacement, that may be rotation or that may be translation, to be unity. For that unit displacement, what amount of force you need there to create that displacement is known as stiffness. But so how you will define flexibility? If you want to define flexibility, then it will be just opposite. You have to bring displacement to the front and force to the back. So now
Okay.
you try to explain it, how you will describe flexibility.
The displacement causes due to unit force.
Yeah. When you apply unit load at a point, due to
Yes,
that unit load, what will be the displacement
displacement.
at that point? That is known as flexibility. Clear?
Yes, sir. Yes.
So flexibility is related to force method, correct?
Yes, sir.
If flexibility starts with F, force method also starts with F. In this way also you can remember. Now, come to axial stiffness. Now, this is a bar member. Sorry. Now, you have to apply a load P to create this displacement as unit. Then, what will be the value of this P? We know delta is given as
PL of
PL by AE.
A.
Correct?
Yes, sir.
Now, what does stiffness says us? What will be the force? Means what will be this P value such that your delta value becomes 1? That means if you put delta equal to 1, that will be PL by AE. From here, you will get PL equal to AE upon L. Now, what is this AE upon L? This is nothing but K of K. K means stiffness, or more specifically, it is for axial members. So you can call it as axial stiffness. Now, come to bending stiffness. Now, this is a simply supported beam. Now, in this case, what is our objective? Our objective is to find the bending stiffness. So, to find the bending stiffness, you have to make the corresponding displacement, which is theta in this case, to be unity. So to make theta as unity, what is the force required? In this case, force is the movement. So you have to calculate what will be the value of M you apply at that joint A, suppose, such that your rotation at that joint, which is theta A, suppose, that should be equal to 1. So what will be the value of M? So let us calculate. This is a simply supported beam. So when you apply a moment M and such that your rotation at this will be 1, unity, not 1, it will be unity. One. Now, when we will do summation of movement about point B equal to 0, first can you tell if we can do summation of movement about point B equal to 0 or not?
Yes, sir.
Yes, because this is a beam and this is a part of our civil structure, and we know that our structure is in the state of static equilibrium. Hence, the equation of static equilibrium, that is summation of Fx equal to 0, summation of Fy equal to 0, and summation of movement about the out of plane direction equal to 0 can be written. So, if you do summation of movement about point B equal to 0, you will get RA. RA is the reaction at this point. RA. I am showing the reaction as well as the hinge support at a time, but this is not a good representation because you cannot show the support as well as the reaction at the same place and at a given figure. You have to draw twice, but I am not drawing it because it is known, well known to you, because reactions and supports cannot be drawn together because the support is the only medium from where the reaction will come due to external. So let us write summation of movement about point B equal to 0. It will be RA into, let L be the length of the beam, L plus M equal to 0. And this is, I am taking clockwise to be positive. So from here you will get RAL equal to minus M, RA will be minus M by L. So we got RA equal to minus M by L. So you got RA as M by L downward. So when you will do summation of movement, summation of Fx equal to Fy equal to 0, you will get M by L upward here with a movement at this point A. Now, can you make what we require? We require theta. So how to get theta? What are the methods you know to calculate slope and deflection at a point?
The moment area theorem or conjugate beam theorem.
Yeah. So which method should we apply here to get it quickly? We can apply any method, but what will be the wisest option to choose from?
Yes. Uh,
You told moment area, conjugate beam.
double integration method is there, but it's quite time taking.
Yeah. Okay. Double integration and um, what else? Okay, we are not interested in highlighting all those methods. So which method should we use?
I think conjugate beam method.
So conjugate beam method you are interested in. So let us proceed with conjugate beam method. For conjugate beam method, you need to determine a conjugate beam of the given real beam. Your real beam is simply supported beam. So real and CB is the conjugate beam. So your conjugate beam also will be simply supported A and B. Now, in conjugate beam, what will be the loading?
The loading will be the bending moment, and it completely depends upon the sign convention
Yeah.
of the bending moment. If
Hmm.
the bending moment is in the compression side, then the arrows will be
So,
downward.
let this be XX at a distance X. So tell me what will be MXX at this section XX. So how your bending moment will look like? At x equal to 0, it is M. At x equal to L, it is 0. So it is 1 degree curve, linear curve, and this will be M by EI here and 0. So M by EI diagram of the real beam will be the loading condition for the conjugate beam. Now you got the conjugate beam. Now what are the relations between real beam and conjugate beam? We know slope at any given point in the real beam will be equal to slope of real beam will be equal to
Your force of conjugate beam.
shear force of conjugate. So we require theta at point A. So we require slope at A. So if we will calculate that this reaction only, our job is done. That will be the theta A of the real beam, correct?
Yes, sir. Yes.
Now how to find this reaction at A? Just take moment about summation of moment about point B. So I don't have any space. Let me add one more slide. So when you will do summation of moment about point B of I equal to 0 for at the rate conjugate beam, you will get RA into L minus half of M by EI into half into base into height into 2/3 of L. That will be lever arm equal to 0. From here, you will get RA equal to ML square upon 3EIL. So ML upon 3EI. But RA is the concept of, or RA is the unknown of conjugate beam. And that is equal to theta A of real beam. So theta A equal to ML upon 3EI. But what is our theta value actually? To determine stiffness, your theta is 1. We are interested for theta A to be 1. What should be the movement? What should be the movement? What should be the movement needs to be applied at this joint A? So put theta A to be 1 and that should be equal to ML upon 3I. From here, you will get M as 3EI upon L. So this is stiffness, or more specifically bending stiffness or simply supported beam. I am not writing simply supported because it is well understood 3EI. So theta equal to ML by 3EI. M will be 3EI by L into theta. But while calculating bending stiffness, your rotation or your displacement should be 1. So put theta equal to 1. You will get bending stiffness as 3EI by L. So till this point, is it clear?
Yes, sir. Yes. Sir, we could have used the moment area theorem, but for my sake of revision, I said because moment area method is easy.
Yeah, but moment area method here, you can apply. I am not telling you can't apply. You can apply, but conjugate beam method here is more suitable.
Preferable. Preferable.
Second,
Okay.
we will do for propped cantilever because it is the most bending stiffness. Because while we will solve the problem, you will face so many questions where this concept, propped cantilever type of beam, you will face. So this is the most important thing, and you should remember how we are deriving because derivation is important for this part. So how propped cantilever looks like?
One fixed end and one roller end.
What is the DSI value?
PSI would be 1.
What will be the KI?
KI would be uh, minus 3.
KI will be 3.
Sorry. 2. 392.
2. Yeah, correct. If
How
the
it would be?
member is rigid,
If the member is rigid, then 1 because there is only one beam.
yeah,
So
there is
no.
no translational motion
Uh-huh.
for this joint B also.
Yes, sir. Yes.
So let this be point A, let this be point B. Now, Here you apply one moment M at joint B such that your elastic curve will look something like this. Now, to determine the bending stiffness, what the statement says, your displacement should be equal to 1. For that displacement to be 1, what should be the force required? So in this case, we need to determine this parameter such that your theta b will be m. So your main objective is to determine m such that theta b is equal to. Now, tell me how to determine that. What can be done?
Uh, if we apply the force method here to solve, then would be one.
So to apply force method, you have to identify the redundant. So first case is this. I have taken RB to be redundant plus when you add this, remove all those external loads. So M is removed. Now I will apply B. Now when you will let this be case 1, C1, let this be C2. If this C1 plus C2 you will add, will you get your original real beam?
Yes, sir.
If I will add this C1 and I will add this C2,
Yes, sir. Yes, yes.
then your real beam you will obtain, correct?
Yes, sir. Yes.
Yeah. Now, due to this M, what is your deflection profile?
Downward.
It will be like this. Due to this RB, your deflection
upward.
profile will be like this. Let this be delta 1. Let this be delta 2. Now, can you calculate what will be delta 1 and what will be delta 2?
Yes, sir.
How?
By applying same the moment area theorem or conjugate beam theorem.
So you calculate and tell me the value. I am not doing it in details because we know how to do it. So I am writing the values only.
Delta 2 is RB L cube by 3EA. Delta 2, RB L cube by 3EA.
Yeah. Okay, I should write it directly then. RL cube upon 3EA. So, but from compatibility, since it is force method, then so to determine the unknown value, what condition do we need? Compatibility condition. Had it been displacement method, then what condition should we use?
Equilibrium condition.
Equilibrium conditions. So from compatibility, you can write delta 1 plus delta 2 should be equal to how much? Is the joint
No.
B moving upward
No,
or
sir. No.
downward?
No.
No. So it will be 0. Correct? Now substitute ml square upon 2ei plus rl cube upon 3ei will be equal to 0. From here, you need r value. So it will be minus ml square upon 2ei into 3ei upon l cube. So upon simplification, what we are getting? Correct? So we got R value to be RB. More specifically, it is RB. So RB we got minus 1.5 M by L. Now, what we need? Till this point, we are not done with our objective. We need M such that your theta B should be equal to 1. But we got RB value only. Now, what can be done?
Uh,
Tell me. You only tell me because after around 10 days you have exam and you should be answerable.
I know, sir.
So now our structure is divided into two. We know this M plus we know this R value. This R value is acting downward because minus 1.5 M by L. Due to this M, it is going upward. Due to this R reaction, now it will come down. Now, with respect to its original orientation, it got rotated anti-clockwise in this manner. Let this be theta 1. And due to this reaction, from its original position, the beam has taken a curved shape, and this rotation from or means initial to final point, let this be theta. Now, what will be this theta 1 value and what will be this theta 2? This will be this will be tell me
Sir,
what will be this theta 2 value?
ml square upon 2ei.
ml square upon 2ei.
Theta 2, right?
Theta 2. How you are how you will
Sorry.
calculate theta 2?
Not ml square. 1.5.
This is just the area under this M by EI diagram, correct?
Yes, sir. Yes, sir. 3 ml 3 ml upon 2 EI.
How much you are getting?
3 ml upon 4 EI. 3 ml square. Sorry, ml.
1.5 m. It should be 1.5 ml upon 2 EI. Means M by EI. This is M by EI diagram, na? So EI 1.5 ml upon 2 EI. Getting?
1.5 upon 2 is 3 by 4. Means 1.5 upon 2. 3 upon 4 is 0.75.
So is it correct or wrong? Means are you getting
Yes,
this
sir.
value or not?
Yes, sir.
That's
I am
what my
getting.
concern is.
Yes,
If
sir,
you
I
are
am getting.
getting same value, then there is no problem.
No, sir. No, sir. I got.
So theta net will be equal to theta 1 minus theta 2. So you calculate ml upon EI minus 1.5 ml upon 2 EI. So take LCM 2 ml minus 1.5 ml. So how much we are getting? ml by 4 EI.
ml by 4 or 0.2? ml by 4 EI.
Now, initially, for stiffness, what should be our theta net value? Or that will be theta net will be equal to theta B unity. So put 1 ml by 4 EI. So from here, you are getting m equal to 4 EI upon L. So these are all standard results. You should remember because you cannot find it that easily during exam. So this m value here will be 4 EI by L. Third case is you have roller this side and you have a shear release this side. This is joint A, this is joint C. Now, when you apply, when you apply a unit, when you apply a movement here, due to this movement, you want unit rotation at this joint A. And it will deflect something like this. So to obtain the bending stiffness for this type of structure or this type of beam, having a roller at one end, at near end and a shear release at far end, you need the value of m such that your theta A becomes 1. Now tell me, and let this be some delta D. Now tell me how to determine this m value for unit rotation for this case. First, you tell me when you will do summation of Fy equal to 0, what you will get.
We'll
If
get
you can tell this point, then everything after that is okay. Means it will be easy.
reaction at A equal to 0.
Done.
Yes, sir.
So this is a movement.
Yes.
So due to this movement, now is your structure is in static equilibrium?
Yes, sir.
Your reaction is 0.
Yes, sir.
So you are applying a movement M at joint A.
Yes,
Due
sir.
to that movement alone, is your structure is in static equilibrium or not?
No.
Then what should be added or how reaction will come such that your structure will come in static equilibrium?
We need to resist the structure or unit. Yes, sir.
Now, is the structure is in static equilibrium?
Yes, sir.
Now, so for this structure, if you draw the conjugate beam again, how the conjugate beam will look like? Tell me. To draw the conjugate beam, you need to go to joints, see the slopes and displacement of your real beam, check if those are zero or non-zero, put analogy, slope is equivalent to shear force in your conjugate beam, bending moment of conjugate beam is equal to deflection is in your real beam.
Real beam.
So how you have to play with the joints for the conjugate beam such that your analogy between the real beam and conjugate beam and its corresponding inputs become same. Same means analogous. It cannot be same but analogous. So I am drawing the conjugate beam. Just check if all those analogy are good or not. This is the conjugate beam of the given real beam. This is real beam. This is conjugate beam. Now, what will be the loading? What will be the loading?
M.
Throughout
M
M.
upon
Throughout M. It will be constant. M by EI.
M upon.
Now, for this structure, you need to determine theta A. So, theta A of the real beam will be equal to what? Of the conjugate beam. This only,
Shear
right?
force. Shear force.
And this will be equal to what? Correct?
Yes, sir.
So, theta A, which is equal to 1, is equal to ml upon EI. So, from here you got m equal to EI by L. So, EI by L is the amount of movement that you need to give at joint A. For what? For rotation of one unit at joint A, which is nothing but our definition of stiffness. I hope till this point everything is clear. If not, you can ask me right now. Clear?
Yes, sir.
So our next concept is the carryover factor. Carryover factor is defined as the ratio of movement transferred at the far end to the applied movement at near end. Like suppose I am doing it for this type of beam. You applied, suppose this is A, this is B, this is MAB, and you got MBA here. You applied movement at near end. Due to this application of movement at near end, some movement get generated at the far end. The ratio of this MBA by MAB is the carryover factor. COF is the carryover factor. That is nothing but equal to MBA by MAB. The third is the most important thing which we'll use throughout the MDM is the distribution factor. So how it is defined? It is defined as the ratio of stiffness of member to the stiffness of the joint where you are calculating the distribution factor. Now see, come to this figure. Let this figure be figure A. Now this M, this is a movement you applied at joint O clockwise. Due to this application, there will be some rotation happening for each and every member at which are getting attached at joint O. So I am showing it differently. So this is A. So you applied movement M at joint O. Due to this application of movement, this beam is getting deflected in this shape. This is getting deflected and taking this shape. This one is getting deflected and taking this shape. This is getting deflected and taking, sorry. And taking this shape. Now, here you are getting some rotation. Here also you are getting some rotation. Here also you are getting some rotation. Here also you are getting some rotation. Now, you have applied movement. You have applied movement at the junction. And this movement is getting transferred to the members in some ratio. It's like you have a fat animal or a fat man and you have a slim man. So you have to push them. So in which to push the fat man, you need more amount of work, means more amount of force, or to push the thin man, you need more amount of force?
The fat one.
Fat one. So now make an analogy. That fat one is nothing but the E and I of the beams.
Yes, sir.
So if E and I of a beam is more, that will attract more movement. It will say give me more movement so that I can give you the required amount of rotation you need. If you don't give me that amount of movement, then I won't do the work for you. That is the thing going on.
Yes, sir.
So the thicker the member, that will attract more movement, and it will get divided in that ratio depending upon the strength of that member. The more stronger the member is, the more movement it will carry. The less stronger the member is, or the weaker the member is, the less movement it will
Movement
carry.
it can carry.
Now,
Great.
now this movement will be M. This is O. All these points are O only, separated to show you how these are done. MOA. This here the moment required for this rotation will be MOB. Here it will be MOA, OB, MOC, and here it will be MOD. And if this is theta AA, this everywhere it should be theta, because this is a rigid joint, and rigid joint like this, suppose this is a frame and there is some load like this, suppose its deflected shape will come something like this, such that before deflection the angle, and after deflection the angle should remain intact. Means before deflection they are perpendicular to each other. After deflection also the deflected shape will preserve that angle irrespective of the loading condition. Correct? Now, if that is the case, then this theta, by what amount this member is getting bent or rotated at this joint, by that amount this, for this member at joint O, that should be rotated. Otherwise the angle, the preservance of angle can't be done if the angles are not same. So MOA is what? Now it will be KOA into theta. MOB will be equal to KOB into theta. MOC will be equal to KOC into theta. And MOD will be equal to KOD into theta. Where KOA, OB, OC and OD, or KIJ in general, are bending stiffnesses. Now read the statement of distribution factor. It is described as the ratio of stiffness of member to stiffness of joint. Now, so distribution factor for suppose member OC you want to write, then what will be its value? Can you tell me? It will be
KOC upon
KOC into theta by KOA
into theta
plus KOB
OB into
theta plus KOC into theta plus KOD into theta. This KOA plus KOB plus KOC plus KOD into theta is nothing but your M. So you are doing MOC by capital M indirectly. So if you take out theta common, it will be KOC by KOA plus KOB plus into theta. When you cut theta and theta, it will be KOC by summation of K ij, where ij represents the near end followed by far end for each member joined to that near end node. So now, can you tell what will be KOC?
KOC.
Yeah.
OC. OC 3I upon L.
Yeah. Then for this KOC, we got 3 EI upon L. For KOD,
Same 3I upon L.
KOA.
4EI upon L.
Now you are getting now why we derived all those formulas.
Yes, sir.
Now my work is done. You have to calculate this for this question and tell me the answer. After that, I will do.
Stephen,
First tell me the stiffnesses. First tell me KOA, KOB, KOC. By seeing the
KO.
figure only you can tell now, because we have
Yes, sir. Yes, sir.
elaborately discussed and done all those derivation related to that equations.
KOA is EI
Uh,
upon L.
EI upon L. Can you derive it now?
Yes, sir. One end is shear hinge and one end is hinge support.
Uh,
So
so you
it
got
is
now,
the
we have
third case.
derived it here. This
Yes, sir. It is the third
case.
case.
Yeah,
Third case.
third case. KO for KOB it is
3EI upon L.
KOC.
4EI upon L.
So for which member you need to calculate the distribution factor?
It's asked the OC.
OC. Then what will be the formula?
KOC upon summation K.
So what is the value of KOC?
Let me calculate.
What to calculate here? I am asking 4EI. Tell me like that only. 4EI upon L, 3EI upon L,
Okay, okay.
EI upon L. You don't have any numerical values over here. So what to calculate here?
4, 3, 8, 4 by 8, 1 by 2, 0.5.
So option C. Now, they have asked for one member. Let let me give you to find for KOA. What will be the
KOA.
value? Yeah.
Oh, DFO.
Okay.
DFO.
ಹ್ಮ್. ಕೋಣಗೆ ಕೆಳಗೆ ಮಾಡಿದೆ ಹ್ಮ್.
0.25.
0.125.
Yes, sir. Yes, sir.
ಸರಿ ಬಾಸ್
DFOB is
ತೋರಿಸಿದ
3 by 8.
Yes, sir.
Now this is question 2. Now read the question and tell me what we need to calculate.
In the figure of question number 1, suppose a moment 2000 kilonewton meter is applied at joint O. What is the value of moment OC? Yeah, we need to just multiply.
Now they are telling for question number 2 that by any means they are applying a moment of 2000 kilonewton meter. So they are asking for member OC, means how much movement the member OC will attract. How much it will attract? It will
It will
attract
simple.
in the ratio of its distribution factor only.
Yes, sir.
So the distribution factor is half. So the answer will be half of 2000. 2000 is the moment value applied, and half is the distribution factor of OC into MA.
So
You are getting
1000.
1000. And that is the option number A. Now, do this question.
Distribution
For
factor for OA, where sir LEI is constant. Okay. KOA EI upon L EI
KOA. Tell me the value of KOA.
yes sir, ये 4 3 7 से 3 2 1 11 1/11 0.
Now, how you are getting those values, I am not understanding. From where you are getting E, I, and L values?
yes sir,
0 point, how you are getting 0 point something? You have to write bending stiffnesses in the form of something A times EI by L. You need to calculate this A value, and if this A value will depend upon your far end joint condition. If that is hinged, then it will be 3EI by L. If that is far end is fixed, then it will be 4EI by L. If the far end is like this, what is this? What type of joint is this?
your range.
If like this shear release, then it will be EI upon L.
Sir, I am telling the answer.
Acha.
Distribution factor.
No. First tell me. Go step by step.
Okay.
OA is EI by L.
Yes.
OB is
3EI upon L.
I was 3EI upon L. Okay. Then OD is
Same 3EI upon L.
all these are correct. If in this type, if you do, then what you are getting for OA? It is 1 by 4,
11.
6, 4, 10, 11. There is no option. So, our options are correct, or you are doing something wrong?
Then it's like that, then I am doing something wrong.
Yeah. KOB is wrong. It will be 0.
How, sir?
Check. Now, if you apply a movement here, okay, and you separate it out, put a hinge, you apply a movement. For OA, you will require some movement to generate that unit rotation. For OD also, you will require some movement to generate unit rotation at joint O or member OD. Similarly, for OC, you know you will require some movement. But for OB, check how OB will look like. This is like this, having a hinge here. So when you will apply some movement, this will
It
directly
will.
translate. Is there any resistance against movement? It will
No.
directly move like
Yes,
your
yes.
trolley bags.
So that's why.
So what is the stiffness? Stiffness will be
0.
0. Now you need
Uh,
distribution factor for OA. So this is the important point you should remember. And I hope one question will come from this part.
yeah.
So be careful. DFOA. So OA will be EI by L upon 0 plus EI by L plus 4 EI by L plus 3 EI upon L. So
The
now
option is
1
correct
by
by 8.
8. So option is option C.
C.
Now, quick.
Calculate the distribution factor for fan OB.
First tell me the distribution factor for OC. Then you calculate distribution factor for OB. Then you calculate distribution factor for OA. Then you calculate distribution factor for OB.
It's a free end, so no movement can transfer.
So what will be distribution factor?
AOC will be 0.
Then OB?
Hello?
Yeah. Now, am I audible?
Yes, sir.
Yeah. Thanks for giving all those hosting rights again. Now, where were we? So, are you getting all those answers?
Yes, sir. Yes, yes.
Yeah. So, which option is correct? Option D.
For which member is
Member
asking joint
OB. OB.
OB?
OB and
Then
OD are
4,
same anyhow.
4 upon 9. Yes, 0.44.
Yeah. Now, let us come to a full-fledged question now. Now, consider the beam in the figure below. They are asking what is the absolute value of the bending moment at B and C joint respectively. So you need to calculate MB and bending moment at joint C. That is MB and MC as per option. Now the first thing you should calculate is what should I do to give you? First calculate what are the KI.
KI.
Consider all those members are rigid in nature. So you will have only translatory, rotations
Rotation.
joints. Yeah. I am getting 2.
PKI. PJ. J K minus R 3
Ki is 2. Now, calculate all those fixed end moments. So, tell me what will be MFAB, then MFBA, MFBC, MFCB. And in our computation, we will take clockwise movement to be positive while calculating. So MFAB will be
WL square upon 12.
WL square by
12.
12. This will be WL square by 12.
12.
This will be P.
WL upon
This
PL
is
upon 8.
W and this is P. Then this
Okay.
is PL by 8.
8.
This will be PL by 8. Just substitute the value and tell me the answers. I don't have the answers with me. Just tell me.
Minus 48 plus 48.
Okay. So I am just writing directly, okay?
Yes, sir, yes.
Plus 48 kilonewton meter. And this one?
24
Minus 24 plus 24
plus 24.
kilonewton meter. So your first step of calculating the fixed end moment is done. This is fixed end moment, not finite element method. Now, once this is done, you need to calculate TF. What is TF?
Distribution factors.
Distributions. Tell me. DFAB, DFBA, DFBC, and DFCB. For CB, you won't get anything because that is fixed. So no distribution factor. This will be 1 because one member is only connected. So total stiffness will be the same as the member stiffness at that joint. So it will, the numerator and denominator both will be cancelled out and it will become what? Unity. Now the thing is, at joint B, what will be the distribution factor for left member and for right member? That are the two members connected at joint B. Tell me. Calculate DFBA. It will be
DF 0.5, 0.5. Both are
one is half means the other one will be also half.
half.
So now we calculated finite fixed end moment, then we calculated distribution factors. Now we need to draw the table, which is called as Hardy-Cross table or iteration table you can mention. I am drawing it, doing it here. First you have to mention joints. Then you have to mention members. Then you have to mention fixed end movements. Then you have to mention distribution factors. Or first you mention distribution factors because fixed end moments you need to carry over. Distribution factor, fixed end moments. So joints are A,
B, C.
C. In A joint, how many members are attached?
1.
One member. In joint B?
2 members.
In joint C?
1.
Distribution factor of A is? Sorry, 1.
1.
BA is? BC is
0.5, 0.50.
not defined.
Not defined.
This is minus 48. Fixed end moment. Minus 48,
Minus 48 plus 48.
48, minus 24, plus 24. Now, next step, you need to balance. Or before balancing, you check. Joint A is a hinge joint. But you are getting minus 48, a movement is acting. Is it possible that the hinge joint will carry some movements?
No.
So you have to release joint A, which is hinge. So how to release? So minus 48 kilonewton is acting. So if you will add 48 kilonewton, then the overall movement or the overall movement at that joint is done. It is 0.
Yes,
So
sir.
from mechanics point of view, now it is correct.
Correct, sir.
Correct. Now, if you applied 48 kilonewton load, 48 kilonewton meter movement there, then there will be some carryover to the internal joint BA or joint B. What will be the value? It will be
24. Yes.
24. Correct?
Yes.
Now you write, this is first part done. Now you write modified. From here you need to sum up again. Modified finite fixed element, I am doing the mistake. Fixed end movements. Modified fixed end movements. Now this is done 0. This is 48 plus 24, it is 72, minus 24 and plus 20. Now you balance all those joints one by one. Now, joint B has a net unbalanced movement of what magnitude? 48?
48.
48?
Yes, sir.
So, 48 kilonewton meter is the net unbalanced magnitude in the joint. So, somehow, if you will give minus 48 kilonewton meter and divide as per the distribution factor to the members, then that joint will be normalized and it will be balanced. Right or wrong?
Yes, sir.
So you have to give minus 48 and you have to divide half. So minus 24 will come and minus 24 will come. Now, how much carryover it will give it to joint A?
Minus 12.
Minus 12. What is the joint type A? It is hinge.
Sorry.
There won't be any carryover.
Sorry.
And this will be
Minus 12.
Now check. Do you need any further balancing? Every joint is balanced. So no balancing. Now add up. This will be 0. This is 72 minus 24 each.
48 plus 48.
This will be minus 48. This will be 12.
Plus 12.
Yeah. So this is 0. This is 48. This is minus 4 or means 48 anti-clockwise. This is 12. So if someone wants you to draw the bending moment diagram and shear force diagram, we are done with this question. We got for B it is 48 and for C it is 12. So option A is correct. But I need you to draw the bending moment diagram also. So tell me how to draw.
First, the whatever. First, we need to draw the free BMD diagram.
What is free BMD?
Free BMD means by removing the fixed end. The
By
what is
removing all those movements.
movement? Yes,
You
fixed
remove
end
all
movement.
those movements. Consider each span as a simply supported beam. Due
Beam.
to loading only, you first draw the bending moment diagram. Just like how you do it for a single span beam containing some loading which is statically
Determinate.
correct. Now tell me this value. It will be PL by 4. 24 into 8 by 4. So 48. Now, once you are done getting all those bending moment at joint, while you plot, you should consider bending moment to be sagging and hogging while plotting, not clockwise anti-clockwise. Remember,
Yes, sir.
0 is 0, so it will start with 0. This 48, try to hog the beam, so minus 48, and try to superimpose on the positive side only. So minus 48 will be somewhat below. So let us keep minus 48. And this will also try to hog the beam. And this minus 12 will also try to hog the beam. So minus 12 will come somewhere here. And this is 12. This is 48. This is 72. And your net bending moment will be shown somewhat like this. Got it?
Yes, sir. Yes. Got a question. Sir, how to calculate the means the final moments means by subtracting positive and negative. How to calculate the remaining nodes? Node means are you getting what I
No, no,
wanted to ask?
remaining nodes means remaining movements means I am not understanding. Every movement, everything is done after calculating, after analyzing the complete structure only you can draw all those diagrams. Even if one thing is unknown, you cannot plot these diagrams. Now you
Uh,
tell what you want to say or what thing you want. Be precise.
means after subtracting the positive and negative movement.
Huh? After
Means
subtracting positive and negative movement. Acha, you want to draw the complete bending movement diagram as it is without superimposing. That is the reason.
yeah, yeah,
You
yeah.
can do for
Sir,
that.
how?
Huh. Tell
I
me
am
what.
how, sir? Means I am doing frequent mistakes to draw. Please, if you
Why
elaborate.
you want to draw it at a go without superimposing? Can I know?
Yes, sir. You may know that because uh, in the book they have done it like that.
Okay.
You
I am
may,
giving
you
hint
may,
how to draw.
yes, sir, yes.
Now, can you find this reaction?
Yes,
This
sir.
reaction,
Yes,
this
sir, yes.
reaction, every reaction from
Yes, sir,
every
yes.
side. If you know this reaction, can you cut the beam into sections? Take take the section like this till this point, such that when there will be some loading change or some EI change or some material change or some movement is coming, till this point, this section will be valid. After you write MXX here, then you shift to this side. You again consider this as some section XX or YY or ZZ as per your requirement. You again write the equation and always take X from a specific point such that you won't fall in any problem. Means while calculating, you might make mistake. So always fix the origin and take X from there only. And write at each and every section, you write the bending moment equation and plot it. You will get the complete bending moment diagram and you did not superimpose there.
Okay.
You got?
Yes, sir, yes.
I don't think so.
Means what?
You got or not? You said yes, sir, in a very low voice.
Uh, Means after practicing, I could answer.
Now see, this 16 kilonewton meter in 6 meters. So overall 96 kilonewton is the load coming, and this will
Yes, sir.
get divided as 48 and 48.
48.
This 48 kilonewton meter bending moment will try to rotate the beam segment AB clockwise in clockwise manner. So due to resist that, you have to give anti-clockwise couple in form of reactions and just add up at each and every joints. You will get all those reactions. Once reactions are done, it is like plotting the bending moment diagram combinedly for a simply supported beam only, or maybe a continuous beam where you know all those reactions. Just go on cutting section by section, write the bending moment equation for each and every section, and at and at each points where you need, get all those values, join that curve, and you will get your complete bending moment diagram in non-superimposed manner. Okay.
We'll discuss after class.
Okay. Now, what is the reaction at B for the beam?
Okay, I'll calculate. B, C.
Now see, this is 16, due to which, and the loading is symmetric into 48 kilonewton due to external load. And this 48 kilonewton meter will try to rotate it clockwise. So you have to provide a anti-clockwise couple, which will come like this. And 48 by length of the panel or segment. This is 6 meter. 48 by 6 is 8. 8. So overall 48 minus 8. The 40 upward reaction is coming here. And here, this is 56 upward is coming. Now come to this part. Here 24 kilonewton is there. So 12 kilonewton, 12 kilonewton. And 48 and 12, net is 36 anti-clockwise it is trying to move. So a clockwise couple will do 36 by, this is 4 meter, 4 meter. So 36 by 8, 4.5, 4.5. So add this up, 12 plus 4.5 in the same direction, it will give 16.5. So 56 plus 16.5, how much you are getting? 72.5 kilonewton meter in the upward direction. Not meter, kilonewton. So option C.
Sir, please. Sir, please, could you explain?
Which part?
Hello.
Which part? Which part?
In the second part, in the BC span, because in the AB span I got 48 upon 6, 8, and to counterbalance means the movement is anti-clockwise movement.
So 48 kilonewton is acting in which direction? Anti-clockwise?
Yes, sir.
12 is acting in clockwise manner.
Clockwise.
So net movement is how much? 36?
36.
36 in anti-clockwise manner. So that 36 will try to rotate the beam in anti-clockwise manner. So how you have to place your couple in form of reaction, you tell me now. In clockwise manner to resist or to keep it in static equilibrium. So
Yes,
I
sir, yes.
made that only 4.5, 4.5 clockwise fashion. So now you just add up at B point this much reaction, 56 plus 16.5 upward, 72.5 kilonewton upwards. Option C.
Sir, means 38 38 divided by 8.
36.
Sorry, 36.
36 divided by 8. You are not getting that. 4.5 it is coming, right?
Yes. Okay. Now I got. It's easy.
Now, within 2 minutes, you tell me the answer. I am not going to solve this question.
Sir, please.
I will just write the answers here.
Wait,
They are asking for DF BA. So it will be you got
Let me, sir, I am writing the previous question. Sir, consider the beam. That is a fixed movement at B for beam BC. I think this. Oh, okay.
T and tell me if you have any doubt. I should not show it like this because those are fixed things. So option D I am getting. Are you getting any other options?
Yes, sir. Yes. Correct.
Correct?
Yes, sir. Correct.
Now, calculate the bending moment at B for the continuous beam for the above question.
Bending moment at
Moment
B.
at B. Now, can you calculate?
Yes, sir. Yes.
Hmm.
KBA, KBC.
Now, how to do? Joint, sorry, joints A, B, C, members AB, BA, BC, CB, distribution factors not given, not given. This will be 0.6, 0.4. Fixed end moments. Fixed end moments will be -4, 4, -15 and 15. Now balance. Now tell me, how much net movement is present in joint B? -11.
Yes, sir. To
So
balance
how to balance?
+11.
+11 needs to be attached or given to balance. So +11 will be distributed to the given jointed members or adjacent members joining at joint B in which manner? In the manner of
As
their
per their
distribution factor.
factors.
So -11 means +11 into 0.6 is 6.6. 6.6 and +11 into 4, 0.4. It will be 4.4. 4.4. Now, carry over. How much carry over here it will come?
3.3 plus 2.2. Distribution factor. Balancing moment. Carry over moment.
So option A is the correct option. Why I stopped there, do you know? Because every joint, the movement got balanced. After that, no balancing is required. Due to the same reason, I stopped there. And you need not proceed any further because there is no movement to balance at any joint. Is this question clear to you?
Yes, sir. Yes.
Shall I proceed?
Yes, sir.
Huh. Now tell me, first tell me distribution factors. DF AB,
Uh,
not defined. DF BA. What will be the distribution factor DF for BA? Tell me,
yes, sir.
what will be the distribution factor?
4 EI upon 20. Distribution factor. KBA upon KBA plus KBC.
That I know. Tell me the value directly.
Value, let me calculate. EI upon 5. Right? DF, BA.
You got or not?
Yes, sir. Yes, sir. I am calculating
Uh,
simultaneously.
which one you are calculating? Fixed end
The
moments
table.
you got or not?
Yes, sir. Yes. I am calculating the table. Yes,
Okay.
yes, right.
You should tell. Otherwise, how I will know?
No, sir. I have just completed one iteration. Meanwhile, you have two. So that's why I'm a bit slower than you. 38.88 minus 30. 5.7 minus. Yes, sir. Yes, sir.
Huh. Now,
Hmm.
again, we have to balance. Wait, make it. Huh.
Where I was calculating 0.87. Hmm.
For a class change. Ah, this will go. Let us stop here. And one thing you should remember that when you are doing this balancing carryover, any number of time you perform, but make sure that you are terminating your results in balancing mode only. You should not keep any net movements if not they are externally available. You should not keep, and always try to keep all those joints in balance condition only. Now, after this much things, you need to sum it up. After summing, you will get, I am writing it here. moments, summation of moments, you will get for AB, it is 25.25. Next is 50.
What happened?
Next is 50.5 minus 50.5, 50.5, 1, 2, 3, 4, minus 50.5 and minus 25.2. So 6, 1, 2, 3, 4, 5, 6. So you got this for which question? When you are assuming that we have made, we have provided here a reaction such that there won't be any sway. This is for non-sway cases. Movements for non-sway cases. Now, since there is 15 kilonewton horizontal load is there, so this frame will try to sway like this. Correct? So, to calculate all those fixed end movements due to sway, first you assume.
Sir, what means?
Yeah, tell me.
Sir, the sway concept, because
Oh, you are not done. Acha.
no, sir, I have done. I got whatever the
So, what is the problem?
that you have explained the sway concept.
Huh. So, that is what I am. This table is for non-sway case. Non-sway case means you are assuming that there is a support here which is preventing this frame from swaying.
Okay.
Correct?
Okay.
You got now? Hmm? Now you tell me 25.25 and this 50.5 will try to rotate this column in which manner? Are you there or not?
Yes, sir, I am there.
Tell me. This will try to rotate it in which direction or in which manner?
The column AB
AB. This
will
left column.
clockwise rotate. Will
Clockwise.
rotate
So
and
how those couple you should give such that they will try to resist? Anti-clockwise.
anti-clockwise.
Here also in similar, not similar manner, in opposite manner.
Opposite manner. They are rotating
What will be
anti-clockwise.
the value of those? It will be 50.5 plus 25.25 by the length of the member, that is 20 meters. This is 3.7875. This is 3.7875. And here it will be 3.7875. Here it will be 3.787. Now, you tell me all those horizontal reactions here are means they are in equilibrium, but this additional 15 kilonewton is making the frame to sway rightward. So here
Yes, sir.
this reaction will come to be how much? From summation of fx equal to 0. Correct?
Yes, sir.
15 kilonewton. Now, next case. Sway case, you have to do it in 2 steps.
Hmm.
Now, with sway. With sway, you have to again make a table. Same joint, members, distribution factor, extend moments, A, B, C, D. A, B, C, D, members A, B, B, A, B, C, C, B, C, D, D, C. Here it was 0.54, 0.46, 0.46, 0.54. Now, extend movements. So when the column is becoming like this, it is same, the case is like this. A beam is there and the one support is getting settled. In this condition, if the one support is getting settled, then you are getting two movements whose values are 6 EI delta by L square. Here also 6 EI delta by L square. And these two movements are trying to rotate it in anti-clockwise manner. So reactions will come. But we are not bothered about reactions as of now. So assume this value as some value, some arbitrary value you assume, because we don't know what will be that value. We don't know how much delta or how much laterally sway is happening. So assume, let us assume to be 100. And since all those movements are coming to be anti-clockwise, so everywhere you write -100. Till this point, it is okay or not?
No,
This
sir.
hmm,
No, sir. No. Please.
not clear. Okay. Means for sway case, first we are dividing the structure into two parts. First we are putting one reaction and analyzing the complete structure as if there is no sway. Correct? We
Yes,
did
sir.
that. We did that and we got all those non-sway cases moment value. Next thing is, but that reaction, that pseudo reaction or virtual reaction, what we have given to make it in non-sway manner, is there any reaction exactly available there?
No.
No. So when you will remove that reaction, it will sway. But
Yes, sir.
how much deflection or how much laterally it will move, do you know?
No.
Don't know. So can you find this value 68 delta by L square, what value it will give? If this is
No,
the
sir.
delta,
No. No.
if
No.
this is delta, this is delta. No,
No.
but can you assume something?
Yes, sir. Yes.
You can assume. You know
Yes,
the
sir.
ratio that A from A to B also it is 6 delta by L square. From B to A also it is, if this is A, this is B, or this is X, this is Y, or this is C,
Oh.
this is B. From C to D also you know the fixed end moment as 6A delta by L square. From D to C also you know it as 6A delta by L square, and both,
Yes, sir.
both are acting in anti-clockwise manner. So what is their ratio? 1.
Yes, sir.
Now you come to this part. So
Uh-huh.
that column A, B and BA
Hmm.
is the only member where there is some like delta displacement is happening, because in BC there won't be any delta displacement. Means
Yes, sir.
means in transverse direction. I am not telling
Transverse direction.
uh, along
Plus
the longitudinal axis, in transverse direction. In BC there won't be any movement as such.
displacement.
Due to no such displacement, there won't come any movement, that is
Movement.
delta by L square in member BC. Correct?
Yes, sir.
Now, but that 6A delta by L square, you know the ratio that MAB to MBA is 1. Similarly, MCD to MDC is also 1, and all are 6A delta by L square. So, can we assume something? A, B, C, 1, 2, 3, 5, 8, anything you can assume.
Yes, sir. Yes. Yes.
So, for simplicity, we are assuming, you can assume unity, you can assume 50, you can assume 100, that's your wish. So, I assumed here minus 100. Because I have solutions for minus 100, that is the reason I assume minus 100. Okay.
Okay.
Now, why minus? Because all are anti-clockwise movements.
Movement.
Now, in the similar manner, you have to fill the table again. Balancing will come. So, minus 100 is there. So, plus 100
Plus 100.
will try to resist. 54, 46. Minus 100, 46, 54. Now, carry over you take. It will be 27. Here it will be 27. And here it will be 23 and 23. Balance. Now 23 is coming. So minus 23 is needed. Minus 23 into 0.54 will be minus 12.4. Minus 12.4 and minus
What will I calculate?
10.58.
23 into
This will be also how much?
plus 10 point minus 10.58.
Now, again you have to take carry over. It will be minus 6.2. This will be minus 6.2. And this will be minus 5.29, minus 5.29. Then again balance it in the same manner. It will be 2.86, 2.43, 2.43, 2.86. Then carry over again. This will be 1.43, 1.43, 1.215, 1.215, 1.43. Again balance it. You will get minus 0.656, minus 0.559. Here it will minus 0.559 and minus 0.656. We did balancing. Balancing till this point. Now again the table will continue.
Hmm.
And here balance. Carry over here it will come as minus 0.33. This side, this carry over minus 0.28. This should carry minus 0.28. This side it will be minus 0.33. This part. And from this. Then again do balancing. Minus 0.28 will be 0.15 and 0.13, 0.13 and 0.15. Then carry over 0.075, 0.065, 0.75, 0.65, then balance it. Minus 0.035, and again here it will be minus 0.03, minus 0.03, minus 0.035. Then again to carry over minus 0.0175, minus 0.015, then minus 0.015, minus 0.0175. Then again balance. This will come out with 0.008, 0.007, 0.007, 0.008. So now when you will sum all those things, you will get minus 78, minus 56.09, 56.09, 56.09, minus 56.09, minus 78. Okay. Now you got right. Now you got for sway case, this is minus 78. So minus 78 will be like this. And after that you got minus 56. Minus 56 also will be anti-clockwise. This will be 56. So this will be 56. 56.05 or 09 is there.
09.
Now this is minus 78. This will be also anti-clockwise. Minus 56 also will be anti-clockwise. So did it some arbitrary. This is 78. This is 56.09. So now you check how this will try to rotate it in anti-clockwise manner. So there will be force like this. 6.71. Similarly, when you will calculate, this will be 6.71. So in this member, 6.71 is acting like this direction, 6.71 is again acting like this. So to keep it in equilibrium, we will do summation of fx equal to 0. This r dash reaction you will get as what? R dash minus 6.71 into 2 equal to 0. So R dash will be equal to 13 point. How much? 13.42. You got na till this point?
Yes, sir. Yes.
Now you got R dash to be 13.42. Means when you are assuming that your fixed end moment is 100 kilonewton meter, considering sway, you are getting this R dash. R dash means this reaction, sway reaction here. Here to get 100 kilonewton meter as fixed end moment, that this reaction is needed to be 13.42. But this 13.42 for 100 kilonewton meter is a assumption. But actual how much reaction is actually needed such that for your real case and what you have assumed, your movement will be same. How much? If your reaction R dash would have been 15 kilonewton, then whatever fixed end moment you have assumed, that would have been correct. But due to assumption of 100 kilonewton, you got R dash to be 13.42. But you need 15 kilonewton. So what is your correction factor?
15 minus.
Not 15 minus. For 13, you assumed 100. For unity, it will be those movement by 13.42. But actual reaction is 15. So into 15, it is unitary method. It will be like this. Now your summation of movement actual will be movement due to non-sway case, that is first one, plus R by R dash into movement due to sway. Now check. This movement you got considering 100 kilonewton meter as assumption, due to which you got reaction to be 13.42. But had it been 15 kilonewton, then whatever you have assumed that would have been correct, you have to just add it. But since those are not same, so for 1 kilonewton reaction, what will be the movement?
15.
Whatever you got now divided by 13.42, it will come due to 1 kilonewton force or reaction. But what is your actual reaction?
15 kilonewton.
So you have to multiply with 15. So M sway by R dash is due to 1 kilonewton or 1 unit reaction. But what is your reaction? It is 15. So you have to multiply with 15 to get the original movements. What is actually happening in the structure. So these two upon addition will give you the overall movement that is acting on the frame. So they are trying to get absolute value of bending moment at A. So MAB will be equal to what you got here, 25.25. That is due to non-sway case, plus R by R dash, 15 by 13.42 into how much? 78
13. 78.
minus 70. So it will be minus 62 kilonewton meter. So option D. You got the algorithm, right? How this is happening. Why that virtual force is coming. Virtual force we are taking for the first case to make it non-sway. Calculate all those movements due to non-sway case. Now calculate the reaction that you need to apply to keep the entire frame in non-sway condition. That is your original reaction. But you don't know how much displacement is happening. that is this delta value you don't know. That is the reason you cannot say this much of that 6 delta by L square. What will be the quantity you don't know? So you assume any arbitrary number and assume and take proper sign convention, that is clockwise positive, else negative. Once you are done, try to fix all those in the table here. Then do balancing, carryover, depending upon the needs where the error will be less. Then sum it up. These are the movements due to what you assume 100 kilonewton fixed end movement. These are the movements coming, but that 100 kilonewton meter fixed end movement, are those real? They are not real. We don't know, we have assumed it like that. So for that 100 kilonewton meter, you got all those movements. After you put it here, you got what will be the forces along x direction. So you saw 6.71 and 6.71 are acting towards this side. So the R dash value will be 2 into 6.71 and that will act in the opposite direction. And that value is 13. But this 13 and your original frame of 15 kilonewton force, are they same? No.
No.
So due to one unit reaction, how much movement you will get? So you just divide it by R dash. Due to actual reaction, what will be the non-sway movement? You multiply with R. That after summing it up, you will get the net movement on that given frame. So that's it from my side. If you have any more doubt, you ask me.
Sir, how to calculate then delta value? The means we have to equate 6 del by L square equal to 62.
Sorry, repeat the question once more.
Means we have assumed that the movement due to the support settlement is 6 del by L square delta.
That is not assumption. That you will get now. There is derivation for 6 delta by L square.
But in question, my point is, if they would ask what is the value of delta, how much settlement in millimeter or centimeter, then how to determine the delta value?
Now you check. You got the actual movements, right? Now?
Yes. Yes.
Now you got the actual movements?
Yeah.
So now you know this 6a delta by L square value, you know or not?
Equal to 62.
No. How come it will be 62? You got MAB to be 62.
Oh.
But now you revert back to your slope deflection equation. MAB equal to MFAB plus.
Okay.
You know everything there. Only the unknown is delta. Now put all those values, you will get the one of your unknown, that is delta.
Okay, in slope declination equation, we need to calculate theta B.
That is the way actually you can find delta. From here you cannot find, because you need equations, na? You need to generate equation. Here we are not generating any equation in moment distribution. That is the beauty of moment distribution. You are not solving any equation. But to determine your unknown, you need to write equation. Without equation, how can you solve your unknown? Correct or not?
Okay, sir. Okay.
Yeah.
So, sir, in previous classes, we have solved the support reactions, movements, and all those things by applying force method. But my question is, can we apply the displacement method to find out the support settlements, reactions, movement for those force method equations? Means the problems that
And
we have discussed.
same thing, na? You see, in displacement methods, your unknowns are displacements. But once your the unknown displacement you know, you can you analyze the complete structure?
Yes, sir.
In displacement methods, your unknowns are displacements.
Yes,
After
sir.
getting your unknowns, can you analyze your complete structure or not?
Yes, sir. Yes.
You can analyze, you can find movement, reaction, blah blah, everything. Similarly, in force method, your unknowns are forces. Once you are done with forces, can't you find deflections? You can use any method, conjugate beam, uh, that double integration, moment area method, any method you can use.
I mean, we can't apply the moment distribution method or slope deflection method to these problems.
Uh, This problem we did it by moment distribution only, na?
No, the previous class problem.
Any problem you can do. That is the reason I said preferably when your KI, if the unknowns are less, that method you need to apply so that you can calculate it easily. Otherwise, it will be cumbersome. That is the only drawback of those methods. And you are seeing all those questions are too lengthy. So you have to be wise while selecting the method. And that will come by practice.
Uh, okay.
So shall I stop or do you have any more doubt?
Sir, I mean, my doubt is to the load transfer mechanism in two-way and one-way slab system.
Two-way and one-way, what?
The load transfer mechanism in two-way system and one-way system.
Now,
The
what are all those two-way and one-way?
means I'm asking the questions from the second chapter of the book. How to transfer the load from the main slab to the supporting beams.
Huh?
The load transfer mechanism
Huh.
for one-way system and two-way system.
Means what is your doubt? One-way system and two-way system are systems. I know.
Means how to transfer. I am getting confused.
How to transfer? How
Can
to
you please?
explain? Explanation is a difficult task because I don't have any figures to explain right now, right? Without figure also I can't explain because you won't understand. For that 3D imagination is needed.
In calculation, I am doing frequently mistakes. To means
Like what calculation you are doing mistake? Huh?
they are assuming the triangular or trapezoidal load distribution.
Huh.
So
No,
I am facing.
that is not a part. Actually, it is given in RC Hibler to make you understand about the loads, types of loads available, and it can, and a structure can withstand. And but that is not the part of structural analysis. That is the part of your design. And I hope you must have read RCC structures. where one-way slab, what you are telling, one-way slab, two-way slab, their length, their aspect ratio plays a vital role while you are calculating all those where if it should be taken trapezoidal cross section, or it should be taken triangular assumption of load. All those things are the part of RCC and steel. Most preferably it is RCC, not steel. Mostly design part of the structures, not analysis part. In analysis part, nowhere you need to consider any triangular assumption or trapezoidal assumption like that. Just what you need to do is to understand all those algorithms, how the methods are different from one aspect or the other aspect, and how you can solve a problem by trick or with ease without making the problem more lengthy and complicated. That is the art you need to learn from this subject. I hope I am able to answer your question.
Yes, sir. Yes,
Hello?
yes, sir. Yes,
Yeah,
I got.
yeah. Any more doubt, or shall I stop?
No, sir.